Okay, topic is light, right? So, as I told earlier, before we move on to the theoretical parts, right? First of all, we have to look what is the significance of this lesson in our physics paper, right? So we will be have definitely an essay question or either structured essay question from this part. If the essay part will be given from the sound waves lesson, definitely structured essay question will be from this one. So last year, structured essay question is from this part, right? Then essay question is from sound waves, right? So most probably this year, essay question will be from light. Structured essay is from sound waves. 27. Make a answer in the full order. May depend on 27. Maybe a structured essay question from this part and essay question from sound waves. And when the full one, so maybe and shift right? So we have a mandatory compulsory and you are definitely essay question or structured essay. Essay question is 7.5 marks. Structured essay is 5 marks. Optics or MCQs, minimum 3 MCQs again, 3 to 4 optics lesson. So 9 or 10 marks may lesson again. Structured essay count 9 marks again. Optics. Essay question 11.5, 11, 10, 11 again. Weight is actually the benefit of the advantage of this lesson is most of the theoretical parts we learned here is independent from mechanics, right? So actually you don't need of mechanics knowledge to learn this one. I make up mechanics that's it. Only the units on geometry unit. Geometrical knowledge of angles and alternative angles, the corresponding angles, knowledge. Right. So what is light? What is light? When I ask you the question, what is light? Light can move at is it how you feel? Light is the it's a kind of energy form, right? So what kind of energy? Light. Over the light, yeah. Over the light waves in a light can energy expressed. Light is the energy form which makes the sense of vision. Vision that is that energy form is known light, right? So is it a wave or particle? Light is a wave or particle? Particle. So wave or particle? Both, yeah. Nowadays they have observed the light exhibits both. So we say that is a wave particle duality. But earlier days, at the beginning, the scientists believed that light is a wave. Actually, beyond that, first case, they have believed that light consists of particles, right? But then it requires a medium to propagate. That medium is known as ether. Ether is the medium that requires to propagate light particles, right? They believe the objects they emit some particles, and that particle comes to our eye and make the sense of vision. object එකෙන් particles එනවා. ඒ particles අපේ ඇටවිලා ඒකෙන් sense එකට vision එකෙන් කියන එක තමයි මුලින්ම believe කරේ. Right? After that, right after a few centuries passed, experimentally observed that light is a wave. The first, actually, it was experimentally observed by Thomas Young. Right? Thomas Young is the person who experimentally shows the light is a wave from his double slit experiment. Young's double slit experiment. I think 1802 is the year. Right? Young's double slit experiment again. He shows that light waves are interfere. They can interfere. They show interference. Right? The only waves can show the interference. You know that. Waves are without interference when another one. Then light shows that. That means light is a wave. Right? So after a few decades, James Clerk Maxwell, right, who was the founder of the electromagnetic theory, who also shows light is an electromagnetic wave. Right? Up to now, we trust light is an electromagnetic wave. It has some region allocated in electromagnetic spectrum. Right? So wavelength of the visible light, the light visible part is in between UV and ultraviolet regions. Right? UV is ultraviolet region වලින් තමයි මේක bound වෙලා තියෙන්නේ. And the wavelength range of light is nearly 400 nanometers to 700 nanometers. Some might say 450 nanometers to 770 nanometers, like whatever. So normally the rough range of the wavelength is 400 to 700 nanometers. Quite a small range of wavelength light has. Right? So light is an electromagnetic wave. Therefore, actually all electromagnetic waves are transverse waves. Right? Since it is electromagnetic wave, light do not require the particle medium, material medium to propagate. It can easily propagate through the vacuum. Right? The speed of light in vacuum is 3 times 10 to the power 8 meters per second. Right? This is the speed of the light in vacuum. But speed in light in the other media or water or glass, it will less than this value, right? Because we know the highest speed that light can get is when it propagates in vacuum, right? So now after few years past, actually end of the 19th century, right? People or scientists also a strange thing that called photoelectric effect. The basic of photo cells or solar cells. When a light or ultraviolet light or X-rays incident on a metal surface, electrons were emitted. That phenomenon is known as photoelectric effect. We have that lesson as our 11th lesson in matter and radiation. Photoelectric effect, we are going to learn it. So in that case, when they try to explain the photoelectric effect using wave theory, they were failed. Right? They treat light as a wave and try to explain the photoelectric effect. Right? But they were failed. So then, Sir Albert Einstein to invent a new concept, which is called photon theory of light. Right? In that theory, he states that light consists of particles called photons. Right? The photons has energy. Energy of a photon is given by this expression, E equals hf. This is Planck's constant. F is the frequency of radiation. So in chemistry, I think you learn this then. Right? So this is E equals hf. Right? So photon is a particle. It has a momentum, but it doesn't have a rest mass. Right? Momentum it has energy. Energy of photon is given by hf. So by using the wave photon period of light, he succeeded by explaining the photoelectric effect. So then, after that, we know light has a dual nature. It has a dual nature. It has a waves properties, and at some point, when we explain some phenomena, we have to treat light as a particle, right? But in this section, in light, under light, and under the geometrical optics, we consider light as a wave, right? We only treat light as a wave, not as particle. Particles will come in net, right? So light is an electromagnetic wave. It has a speed in vacuum which is 3 times 10 to the power 8 meters per second, right? So studying about light waves or light in physics, there are two. We can classify that into two ways or two sections. When you go to the universities, and if you are going to study physics further, most probably second year you are going to study about light optics, right? So in there you will learn another part of light, right, which is not going to study in our A-level scope, right, which is known as physical optics. Physical optics. Physical optics. Or wave optics, physical optics, right? The other part is the one we are going to study, or we are going to start today, which is geometrical optics. Physical optics, local university physics second year physical optics. Right? So what is the difference here? Right? And what is the difference? Geometric and physical optics. Difference. Here in geometrical optics, we consider light waves travels in straight lines. They travels in linear path or straight line. We consider the straight line behavior of light. Right? So we define light rays and study about light. Right? We are not going to learn about the wave nature. We are not going to consider the wave fronts of light. Only we create light. They is traveling in linear paths. Right? Api light color radial. Chandana api radial mega. Or solar radial chandana color. Right? In physical optics, we study about the wave phenomena of light, like interference, diffraction of light, polarization. Geometrical optics, we study about refraction and reflection, which we can express using the linear behavior of light. Geometrical optics is very simple. Straight line, light down. Wave becomes the future and then. We are not going to think like as this. So when you ask to represent a light wave in geometrical optics, we use this imaginary light, which is called a light ray. We use light rays to study phenomena in geometrical optics. So what is a light ray? What is a light ray? Light ray it is an imaginary line which we use to show the direction of propagation of light. Light ray is an imaginary line we use to show the direction of propagation of light. Right? So how do you show the direction of that light wave? Are you using the arrow? Okay. This arrowhead is always pointing towards the direction where the light wave travels. Right? Okay. So this is a light ray. So we use a straight line to represent a light ray. Right. So what about this? So if you take several light rays like this. Right? So light consists of several light rays. It may be like this. Or like this. Right. So what is this? A portion of like, so several light rays. If we take several light rays together, we call it as a beam. It's a light beam, right? So there are three types of light beams you can see. Right? These are the three types of beams. This one, parallel beams. Parallel beams, right? Then this one, yeah, this is converging. Converging beam. This is diverging. Like beams types, right? So අපි beams and ඔය මේ කියන light rays වලින් තමයි මෙතන ඉස්සරහට වැඩි කරගෙන යන්නේ, right? So if a two or more light rays coming from an object, right? Suppose we have object here, I point object, and we have some optical instrument here. Suppose it is a lens, right? So somehow two or more rays coming from this object, we converge, we make to converge to a point, right? We make it converge to a point. So that on that point we say an image of this object is formed, right? If a two or more light rays converge, two or more light rays coming from an object, somehow, right, converge together at a point, we say on that point an image of object is formed, right? Sometimes actually these light rays do not really converge to a point, right? Suppose this is object, we have a concave lens here, right? So the light rays are coming from the object, it diverges, and it diverges as if the light rays coming from a point right at here. So if we see the image of the object, actually light rays are not really meet at a point, but we can see, right? අපි පේනවා ඒක really make a point වෙන්නේ නැහැ, but we can say light rays are coming from certain point. So here also an image is formed, but these two images are different in nature. If the light rays are actually converged to a point, meet at a point, this image is called a real image. This image is real image. Light rays are actually connected together, but here it appears to be meted somewhere. So image format here, it is a virtual one. It is a virtual one. Right? It is a virtual one. Right? So image formed by image of object formed by optical instrument may be real or virtual. Right? Over real වෙන්නේ rays ඇත්තටම එකට intercept කරලා meet වෙනවා. But it appears to be meted somewhere. Image formed at that point is a virtual one. So these are the fundamental things you need to know before we move to the refraction of light. Right? So this is the introduction part. Okay? I'm going to note that down. The topic light. light is the yes. Because the waves are away, unbook waves of your properties of wave here can away, unbook waves again, waves part, you know. Light is the form of energy that stimulates our sense of sight. It is an electromagnetic wave. It is an electromagnetic wave that can travel through a vacuum. Speed of light in vacuum is, I normally use simple C. C equals 3 times 10 to the power 8 meters per second. Right. The next passage. It occupies a small segment of electromagnetic spectrum. Which has the rough wavelength range of 400 nanometers to 700. Rough wavelength range of 400 nanometers to 700 nanometers. Right? Sorry. Okay, some are 450 range. Normal, they can make it. The average is 400 to 700. Maybe 380 to 77. Right? That's normal. Right. Next. In physics, we study about light in two different fields. In physics, we study about light in two different fields. The first one is geometrical optics. geometrical optics. Geometrical optics. The second geometrical optics is here we consider here we consider light travels in a straight line. And second one is physical optics. Physical optics. Right? Here we consider the wavelength of light. Right. So now onwards, we are going to learn about geometrical optics. Right? With the topic geometrical optics. Geometrical optics. If you want to study about physical optics, go to physical science or biological science and study physics as a subject. We can go campus physical, biology science and physics. Physical optics. Geometrical optics. Right under it. In geometrical optics, we assume light is traveling in straight line paths. First one, straight line paths. Reflection and refraction. Reflection and refraction. Phenomena can be studied using this assumption. Right. Here we use light rays. To describe or to explain refraction and reflection of light. Refraction and reflection of light. Here we use light rays to explain refraction and reflection of light. Right. Next subtopic is a light ray. A ray. Light ray. Right now, a light ray is an imaginary line. A light ray is an imaginary line. A light ray is an imaginary line that represents the path along which light travels. An arrowhead is used to show the path, show the direction the light ray travels. Right. So you can draw this light ray here. So you can use an arrowhead to represent the direction. Right. Next. Ray ke vitra ya. Dan ya na. A beam of light consists several light rays. There are three types of light beams can be observed. There are three types of light beams can be observed. First one, parallel beams, converging and diverging. Next topic is image. Image formed by light. Image formed by light. Image formed by a light. Yeah. An image formed by a light. An image formed by a light. An image formed by a light is the an image formed by a light is the an optical reproduction. An optical reproduction. Image formed by a light. Image formed by light is an optical reproduction of an object. Optical reproduction of an object. Of an object produced when light rays from the object refract or reflect images can be real or virtual. Images can be real or virtual. Like real images clearly are assigned real images. Real images. Real images. Right in front of it. Then it's right. Right? Yeah. Real images are formed when light rays. Real images are formed when light rays actually meets. Light rays actually meets. Right? These images can be projected onto a screen. And usually inverted. They're usually inverted. Real images are usually inverted. Then virtual images. Virtual images. Virtual images. Virtual images are formed. Virtual images are formed when light rays only appear to meet. Only appear to meet. Only appear to meet. These images cannot projected onto a screen. These images cannot projected onto a screen. Screen here is done about virtual layer. right? So normally they are upright. They are normally upright images, virtually upright. Right? Upright images are virtual. I make up normally, but I cannot like make up there. Here it appears to me. Here actually means. Right. This was the topic, refraction of light. Refraction of light. Refraction of light. Refraction of light. So we did discuss about refraction of waves last week, last Sunday. Discuss. So what is refraction means? Refraction. We define refraction of a light wave. What is refraction again? Change in direction. When a light wave or light ray, so light wave enters to another medium, second medium, right? The direction of propagation of the light wave changes. What is the reason for that? Why the light rays get refracted? Change of speed of the speed of propagation of light waves differs from medium to medium. That is the reason for the refraction, right? So all the light waves refract according to two laws of refraction. They obey two laws of refraction. And what are those two laws? So this is refraction. Suppose this is the interface, and This is the incident ray. It's supposed to go this way, but due to the change of speed, light ray bends. Right? So we draw a normal to this point. This is the normal. Right? This is medium 1. This is medium 2. So as you know, we measure angle with the normal. So the angle made by incident ray with the normal is I, which is incident angle. This is refracted angle. Right? This is incident ray. Incident ray. This is refracted ray. I is angle of incidence. R angle of refraction. Right, so what are the two laws? The first law states, first law, what did it say? Incident ray, refracted ray, and normal drawn to the point of incidence. All three lines on the same plane. Right? So second law, which is also known as Snell's law. Second law states that the sine value of incident angle over sine value of angle of refraction is a constant. This is a constant. So this law is known as Snell's law. It's also known as Snell's law. So here, sine I over sine R, we write it as 1n2. So what is this 1n2? This actually 1n2 means refractive index of the second media relative to our first media. So actually it is a refractive index which depends on the speed of light in both these mediums. 1 and 2, which is known as relative refractive index. Relative refractive index. If it is a 1 and 2, this is how we define it. Again, 1 and 2 is speed of light in first medium over speed of light in second medium. Right. So this is how we define relative refractive index. Speed of light in first medium over speed of light in second medium. This is the relative refractive index. So you can write Snell's law in terms of the speeds like this. Sine I over sine R is V1 over V2. So this is the one way of expressing Snell's law using speeds of waves. Right? This is from the relative refractive index use kala. Right. Note down this. Refraction of light. Again, when a light wave, yes. I will show you. Right? Other, yeah. When a light ray travels from one medium to another, path of the light ray in second medium changes. Uh, Path of the light ray changes to the changes to the this is due to the change in speed or change of speed of the light ray. This is due to change of speed of the light ray in the second medium this phenomena is known as refraction. This is known as refraction. Right. So when light rays undergo refraction, does the frequency change or not? No. Frequency remain constant. Velocity and wavelength change. Right. When a light ray undergo refraction, frequency of it remain constant. But wavelength changed. Right. So in when refraction, we have two mediums. We categorize or we classify two mediums in rare medium and denser medium. So what is a rare medium? Distance, elastic pure. The medium where the speed of light is greater. High. Denser medium, the speed of where the speed of light is yeah. In refraction, we classify two mediums or two media. We classify two media as rare and denser medium. As rare and denser medium. In rare medium, refraction, we classify mediums as rare and denser mediums. In rare mediums, speed of light is greater or higher. Denser medium, speed of light is lesser. Next topic is laws of refraction. Laws of refraction. Last week කරපුව තමයි අපේ optics වල ඒ ටිකයි කියන laws of refraction. Laws of refraction. Right. So you need to draw this first. Draw this diagram. Okay. Finish. Alright, then the first law. First, alright. Yeah, first law. And incident ray, refracted ray, and normal drawn to the point of incidence. All three lie on the same plane. All three lie on the same plane. Second law. Sine value of incident angle, sine value of angle of incidence sine value of angle of incidence over sine value of angle of refraction. Sine value of angle of refraction is a constant. It's a constant. Right. Sine I over sine r is constant. Is 1 and 2. The 1 and 2 is the refractive index of second media relative to first media. Right. Then, no. Relative refractive index. Relative refractive index. Relative refractive index is a constant. It's a constant which depends on the speed of lighting to mediums. Speed of lighting to mediums. Right. So relative refractive index, like the definition, speed of light in first medium divided by speed of light in second medium. One and two is V1 or V2. Are there? Right? So you can express Snell's law in terms of speeds. Right? This is the so this is the Snell's law. This is the form of Snell's law in terms of speeds of light. Speeds of light. right? So there's another refractive index code. Absolute refractive index. Absolute. Absolute refractive index. Absolute refractive index. So what is absolute refractive index? Absolute refractive index means refractive index of a media relative to vacuum. Refractive index of media relative to vacuum is absolute refractive index. Right? So absolute refractive index, absolute refractive index defined in terms of speeds. Speed of light in vacuum. Divided by speed of light in medium. So absolute refractive index N equals speed of light in vacuum is C over V. Then atomic absolute refractive index. Absolute refractive index. Absolute refractive index. Right now. Absolute refractive index. Yeah. Absolute refractive index. Absolute refractive index is the refractive index. Sorry, absolute refractive index. Absolute refractive index is the refractive index of media or refractive index of medium relevant to vacuum. Actually, it should be respect. Relevant respect to vacuum. Right? So absolute definition, absolute refractive index equal speed of light in vacuum divided by speed of light in medium. Write an example question. Speed of light in glass. Speed of light in glass. Speed of light in glass is 2 times 10 to the power 8 meters per second. 2 into 10 to the power 8 meters per second. Find the absolute refractive index of glass. Find the absolute refractive index of glass. Right. 1.5. Huh? Is there a? No. Refractive index is just a constant. Right? So C is 3 times 10 to the power 8 divided by 2 times 10 to the power 8. Answer is 3 over 2. Or you can say 1.5. Right. So let's express relative refractive index. Relative refractive index in terms of absolute refractive index of two media. So here, suppose two medias have absolute refractive index of N1 and N2. Media 1 refractive index is N1. This is absolute one, right? So, in a question, if they have given refractive index directly, like refractive index of water this much, refractive index of light, glass this much, that means absolute refractive index. If it is say refractive index of glass respect to water, then it is relative refractive index, right? The company equal refractive index is absolute one. Respect to Abu, right? Okay, so this is media 1, media 2, ray enters to media 2 from 1 and get bent like this. Right. Now the speed of light in first media is v1, speed of light in second media is v2. So now we are going to write an expression for n1, n2. So 1 n2 is v1 divided by v2. 1 n2 is v1 over v2, right? So what is n1? n1, absolute refractive index of first media is speed of light in vacuum divided by speed of light in media 1. n2, speed of light in vacuum over speed of light in media 2. So what if equation 2 divided by equation 1? n2 divided by n1. C over v2 divided by C over v1. C over v2 into v1 over C. So n2 divided by n1 is v1 over v2. Right? So v1 over v2 is here n2 over n1. So 1 n2 equals refractive index of second media divided by refractive index of first media. And refractive index of second media respect to first media is absolute refractive index of second media divided by absolute refractive index of first media. Right? So if it is so, Snell's law, this is the form you need to use in calculations, right? Make one sin I over sin R equal 1 and 2. Sin I divided by sin R. 1 and 2 is N2 over N1. 1 and 2 is N2 divided by N1. Then to the cross product, N1 times sin I equal N2 times sin R. So this is the form of Snell's law, right? You need to use in problems. This is the simplest way. N1 times sin I, N2 times sin R. So what is N1? Refractive index of the media where the incident ray is. What is N2? Refractive index of the media where the refractive ray is. Right? So N1 sin I, N1 times sin value of this equal N2 times sin value of. Right? Now tell me. So we do a numerical example here. This angle is suppose 30. This angle is suppose 19 or something. Right? Refractive index of this media is 1. Refractive index of this media is 4 divided by 3. Now use Snell's law. What is the expression you can write by looking at the refraction here? What is N1? 1. Sin I is 30. Right? What is N2? 4 over 3. Sin 90. Okay. Right? මෙතන අපිට මේක දන්නේ නැහැ කියලා මේකයි හොයන්න ඕනේ. I is sin R then. Sin R. So how do you find the sin R? You need to simplify this. Sin 30 is R. 4 over 3. Sin R. So subject sin R. 3 divided by 4. 3 over 8. Now you need to simplify this, right? So get the answer to 4 digits, right? 3 over 0, 30 over 0, 3, 24, 6, 7, 60 over 0, 7, 5, 0. Digit then go to sign table and then sign table and give 0.3750 relative angle. Respect angle. Okay. Star mark expressing star mark point factor expressing relative refractive index in terms of expressing relative refractive index in terms of absolute refractive indexes. Absolute refractive indexes of two mediums. Right. So you can write this. Because V1 can speed of light in first media, second media. Write down this. In another way, expressing Snell's law in terms of absolute refractive index. Expressing Snell's law in terms of absolute refractive indexes. Expressing Snell's law in terms of absolute refractive indexes. Expressing Snell's law in terms of absolute refractory indexes. In terms of absolute refractory indexes. I want to make an example here. Right? Right. Hang on. The example how to use the Snell's law. Again, N1 and incident angle media first media first media refractive index incident angle is sin wave एक product equal है second media के incident angle के sin wave absolute refractive index right वो पापा right that's what the idea was over and done it so we follow second से high table absolutely When direct then or refractive index absolute Right. So, remember, if a light ray in refraction, when the light ray, right? In refraction, when the light ray enters from rare medium to denser medium. So, how do you know the refracted ray? It bends towards the normal. It bends towards the normal. If a ray comes from denser medium to rare medium, it bends away from the normal. It bends away from the normal. Right. Then angle of deviation. Angle of deviation. So how you get the angle of deviation? So suppose this is the ray, incident ray. This is the refracted ray. So what is the angle of deviation? This is the original path of the ray. Right? So now you can see when the ray bends towards normal, yes, it has deviated some angle laterally. So this angle, this one is known as angle of deviation, capital D. Capital D. So how do you find this angle of deviation? What is the deviation of angle here? I minus R, right? In the opposite, by taking the opposite angle, this angle is I, then subtract this small angle R. So D is angle of deviation here is I minus R. So what is the direction of this angle of deviation? Clockwise or anti-clockwise? Here it is a clockwise. Right? This is the angle of deviation while the refraction occurs. Right. So if the case is here, if the case is like this, ray bends away from the normal. This angle is R. So this is I. This angle is R. So now what is the angle of deviation? Now what is the angle of deviation for this refraction? What is the angle of refraction? Sorry, angle of deviation. R minus I. This angle is R, and from the opposite angle, this is I. So D is R minus I. Direction is hand is anti-clockwise. Anti-clockwise. Right? So if a light ray get refracted from several surfaces or several interfaces, how do you find the total deviation of angle of this ray? You need to add angle of deviation of each refraction algebraically. Right? If you take clockwise, the angle of deviations are positive, then the anti-clockwise angle of deviations are considered as negative. එකින් එකට එකතු කරන්න. දැන් මේක මේ ඉන්පුට් තියෙනවා. ඊළඟ සර්වර්ස් දෙකක් තියෙනවා. ඔය එකක් වෙනවා මෙහෙම. මේකෙන් කොහොමද ගියේ? මේකෙන් කොහොම යනවා? This angle is I1. This is R1. Make a R1. This is I2. So how you get the total angle of deviation? Right here, the angle of deviation is clockwise, which is suppose it is equal to D1, I1 minus R1. Here, angle of deviation is anti-clockwise, should be I2 minus R1. Angle R1 is, but again, alternative, right? So D1 equals, so D equals D1 plus D2, but algebraically. If we take clockwise angles are positive, D1 is positive. So it is I1 minus R1. But here D2 is negative. So it should be negative I2 minus R1. There are the negative in look at the make a clockwise and deviation negative. Make it anti-clockwise. So take a negative here. Consider that. So I1 minus R1 minus I2 minus plus and plus R. So angle of deviation, total angle of deviation of the ray is I1 minus I2. Total angle of deviation is I1 minus I2. Right? That is how you need to get the angle of deviation. Right? When the light ray, when the light ray sorry, topic anyway. When the light ray refracts, the light ray refracts from rare medium to denser medium. And light ray refracts the rare denser medium, it bends towards the normal. It bends towards the normal. It bends towards the normal. Sorry. Click away. Make a video. Second well. Ilong ikay ang niya, make it right. When light ray refract from denser medium to rare medium, when the light ray refract from denser medium to rare medium, it went away from the normal. Kata lagi. Thank you very much. It was an angle of diffusion, refraction. Angle of deviation, refraction. Yeah. Angle of deviation. Okay. Yes. Three different medias. Right. So what if a light ray incident along the normal drawn to the interface? What happens? Light ray comes along the normal incident. Huh? That doesn't refract it. It keeps that same path. Those lines. Right? So a light ray incident along the normal means incident angle is 0. So we can see the refraction. Although the speed of light ray gets reduced or changed, it doesn't deviate. It can deviate very net. Right? Take up special case here. When a light ray incident along the normal drawn to the interface. Normal drawn to the incident. Normal drawn to the incident. when a light ray incident along the normal drawn to the interface. Normal drawn to the interface. It does not refract. Right. Again. Right. The refraction of light is reversible. That means, right, if the incident angle on the first media is simple I, and the angle of refraction is R. Suppose the angle of incidence is simple I in the first media, and the angle of refraction is R. Now, if the ray comes from second media to first media, and the angle of incidence on the second media is R. So what is the angle of refraction in first media? Angle of incidence in first media is I, and the angle of refraction is R in second media. Then what if the rays come from second media to first media, right? If the incident angle at second media is simple R, what is the angle of refraction at first media? It should be I, this I, right? Because refraction of light is reversible. Reversible means if a light ray comes this way and goes this way, if you refract it, it takes the same path opposite. Incident angle R, refract angle right? That is why for refraction of light is reversible. Right? Refraction of light is reversible. That's some important facts about refractory index. One is, so 1 and 2 equals 1 over 2 and 1. 1 and 2 equals 1 over 2 and 1. Means refractory index of second media respect to 1 is equal to 1 over refractory index of second media. So the refractory index of first media relative to second. So how we prove this? Right? So here 2 and 1 means speed of the light in second media divided by speed of light in first media. So get the reciprocal of this. V2 over V1. Which is V1 over V2. So 1 over 2 and 1 equals V1 over V2. So what is V1 over V2? V1 over V2 is 1 and 2. 1 and 2. Right? The second relationship. 1 and 2 times 2 and 3. 1 and 2 times 2 and 3. What is it? 1 and 2 into 2 and 3. It is 1 and 3. 1 and 3. How you prove this? See, 1 and 2 times 2 and 3. 1 and 2 is V1 over V2. 2 and 3 is V2 over V3. V1 over V2. So V1 over V3, this is 1 and 2. These are the relationships. Third one. 1 and 2 times 2 and 3 times 3 and 4. Capital N minus 1 times capital N times. Finally, capital N simple N1. Right. So what is the final? 1 and 2 times 2 and 3 times 3 and 4 move around. Finally, capital N simple N1. What is the different answer? 1 and 2 times 2 and 3 and 1 and 3. And then it was 1 and 3 times 3 and 4 and 1 and 4. So we give the whether to know. But then n minus 1 එකක් කරන වේදන n minus 1 වෙයි වෙනයි කියන්නේ නේද? ඔකේද? ෆයිනලි අන්තිමට එන්නේ මේ මීඩියම් එකයි මෙතන මීඩියම් එකද අන්තිමට ඉන්ඩෙක්ස් එක එන්න ඕනේ. So final one is 1 and 1. 1 and 1 means so write down these relationships. And make a proof එක පොඩි දේවල් ඕවෙන් ඉස්සරහට ඒකයි
Then break that down. Now, we the first thing, the color.